Today we're going to evaluate polynomials by using synthetic substitution, which is also called the remainder theorem. It is called the remainder theorem because the remainder will be the answer for the problem. Looking at example 1, I have f of x equals x to the third plus x squared minus 3x minus 10. And I'm going to evaluate this polynomial at x equals 2. So when I set this up, I'm going to put 2 here, just as if it was a divisor. I'm going to bring down my coefficients, and remember, I have to bring down my coefficients in descending order. So x to the third, there's an understood 1 there. X squared, there's an understood 1 there. Negative 3 and negative 10. The steps are the same for synthetic substitution as they are for synthetic division. So I bring down my 1, which is my first term. You know, I always bring that term down. 2 times 1, I multiply now. That gives me a 2. I add up and down. 2 plus 1 gives me 3. I multiply. 2 times 3. That gives me a 6. I add up and down. So negative 3 plus 6 is going to give me a 3. I multiply 3 times 2, and that's going to give me a 6. My remainder is a negative 4. The remainder is the answer to the question. How do I check this? How do I know if this is true? So I'm going to check this using direct substitution. So I'm going to take the original equation. Everywhere for x, I'm going to plug in a 2. Once I do this, I'm simply going to simplify. 2 to the third is 8 plus 2 squared is 4 minus 3 times 2 is 6 minus 10. I'm going to combine like terms here, and when I combine like terms, 8 plus 4 is 12. 12 minus 6 is 6. 6 minus 10 is a negative 4. Those answers are the same. You can always check your work using direct substitution. So we're going to do this one more time. We're going to do example 2. So for example 2, I have f of x equals x to the fourth plus x squared minus 3x plus 1. And I'm going to evaluate it at x equals negative 1. So I'm going to bring down my negative 1 over on the side. So negative 1 here. I'm going to bring down my coefficients. I have a 1. I have a 0. I have a 1, a negative 3, and a 1. So now the question is, why do I have that 1, that 0, right? Because it skips a power. It goes x to the fourth, and it skips the term x to the third. So remember, I always have to have that placeholder there. So my coefficients are 1, 0, 1, negative 3, and 1. Now I can bring down that first 1. Always bring that down. 1 times a negative 1 is a negative 1. When I add 0 and negative 1, that just gives me a negative 1. Negative 1 times negative 1 gives me a positive 1. When I add them, it's a 2. 2 times negative 1 gives me a negative 2. Negative 3 plus a negative 2 is a negative 5. Negative 1 times negative 5 is a positive 5. my remainder, which is my answer, is 6. So now, let's check it. Let's see if it works. So my original polynomial is x to the 4th. So instead of putting an x there, I'm going to plug in that -1, which is what I evaluated the polynomial at. So -1 to the 4th plus -1 squared minus 3 times -1 plus 1. Please remember to use the parentheses, okay? Please use the parentheses. So -1 to the 4th power is just 1. -1 to the 2nd power is just 1. -3 times -1 is going to give me a +3. And then I bring down the 1 on the end. When I combine like terms, 1 plus 1 is 2. 2 plus 3 is 5. 5 plus 1 is going to give me a 6. So again, you can always check your answer using direct substitution to make sure you're correct.